Hello my shimmering stars, today I Shaurya Grover welcome you all to this amazing platform of PW English. Students, I welcome you all to your Nexus Batch and today we are going to start with lecture number 4 based upon the chapter P block elements. I hope so students, you have seen the previous class, you have done the questions and now you are able to understand it very well. So students, this is going to be our last lecture today and we are going to wind up the inorganic part in your Nexus batch today. I hope so this journey you have done, a lot of hard work, you have understood a lot of topics and you have clarified your doubts as well. Yes. Now in this particular journey, I enjoyed a lot with you people, but I don't know about you all, yeah? And I will only be knowing when you are going to practice questions. Yes. So students, the homework that I have given you, okay, what I will be doing is like, within a day, I'm going to pin the answers of all the homework questions till now we have done so far. So in the comment section, you will be seeing a pin over there as the answers of the homework question given. So you can just go and check over there of all the homework questions till now that I've given you over, for example, in S block chapter, in P block chapter, whatsoever questions are being assigned, their homework will be pinned within a day, okay? So you can cross check your answers over there and can see yourself and you can do the self analysis that whether you were able to solve that or not. Yes, everyone. And if you feel any doubt is there, just write your doubt in the comment section. I will be answering to you over there as well. Yeah. See students, this journey is not going to end up over here only. We are going to proceed further, till your exams. So I will be there. I will be meeting you on the PW English channel again and again. But yes, the inorganic part we have finished up over here for class 11th. In class 12th, we'll be doing, the P block 15th, 16th, 17th, 18th group. And the next part that is basically DNF block. But if I'll talk about class 11 syllabus, so this is going to be the last lecture for inorganic chemistry. Yes, everyone. So students, let's start this journey of, the last session of our Nexus batch over here. So, how are we going to proceed? What are we going to, do today? Let me tell you students. See, first of all, we shall be understanding about the chemical properties of group number 14. In the previous class, we have already covered the physical properties, everyone. But now it's turn to do the chemical properties. That means what is, the reaction with oxygen, the reaction with water, the reaction, with halogens. So we're going to do that. After that, students, we'll be understanding about the compounds related to the group number 14. And at last, students, it is going to be the allotropes of carbon. Yeah. So this is basically how we are going to proceed in this particular class today. Let's start with the very first topic, that is basically the chemical properties. And in chemical properties, let me tell you, they are saying reactivity towards oxygen. So whensoever we are saying reactivity towards oxygen, we'll be referring to as, the carbon family members. How are they going to react in the presence of air? So students, when they are reacting in presence of air, they are either going to form monoxides or they are going to form dioxides. Okay. Let me first of all write the carbon family members. So it's carbon, silicon, germanium, tin and lead. These are the members. Now as I've already told you, what they can do is they can either create monoxides or they can either create dioxides. Yes, everyone. Now, let me tell you, when carbon creates a monoxide, CO, basically it is neutral. Okay, and if I'll talk about the other members over here, see, carbon in the form of dioxide is CO2. Silicon in the form of dioxide is SiO2. Germanium will be GeO2. Tin will be SnO2. Lead will be PbO2. Yes, everyone. Yes, everyone. So, among these, the top three basically they are acidic. And the rest two will is basically is amphoteric. So such questions can be asked upon them, and if I talk about CO, basically it is neutral, everyone. Just take a note, just write each and every key point which I am telling you over here with regard to the monoxides and the dioxides formed over here. Clear, everyone? Moreover, they can also create monoxides such as CO, SiO, GeO, SnO, PbO, yeah, these are the monoxides, but the questions generally asked from this side, and for CO it's neutral. Rest, if I talk about CO2, SiO2, GeO2, they are acidic, SnO2 and PbO2 are amphoteric in nature. Coming to the next part, students, let's understand the important key highlights of the reactivity with oxygen. See now, SiO only exists at high temperature. So these I have written, the important key highlights that you can write down in your copy. You can, highlight in the NCERT as well. So as I have told you, SiO, it is a monoxide of silicon. It exists only at a higher temperature. Let's talk about the next one. Oxides in higher oxidation states of elements are generally more acidic than those in the lower oxidation state. So the ones which have +4 oxidation state will be more acidic than the ones which has a lower oxidation state value. So the oxidation state you generally know for the carbon family, it's either +4, it's either +2. This is the general oxidation state that we talk about. Yes everyone? Okay ma'am. Now coming to this over here, the dioxide, if I'll talk about CO2, SiO2 and GeO2, they are acidic, which I have already told you, whereas SNO2 and PbO2 are amphoteric in nature. So this I have already written in the previous slide. I hope so you all have written that as well. Now students, among the monoxide, CO is neutral, which I have already told you. GeO is acidic, whereas SNO and PbO are amphoteric in nature. So if you want to write for the monoxides also, you can write it over here students, but generally the question is asked from carbon monoxide, that is CO. See, when it is creating monoxide, okay, so it is going to be carbon monoxide, silicon monoxide in that way. When it is creating dioxide, so it is CO2, SiO2, GeO2, SNO2, PbO2 in that way. Yeah everyone, I hope so the reactivity towards oxygen is very simple and you are able to understand also. Now let's start with the next chemical property of ours, that is basically reactivity towards water. It's very interesting students, let me tell you. In reactivity towards water, you should know that only and only tin is going to react with water and going to create its hydroxide. Rest everything is not going to do so. Why rest everybody is not going to do so? See, carbon, silicon and germanium are not affected by water. Do remember that they are not affected by water. Coming to the next part, if I talk about lead, that is Pb, it is unaffected by water. Why? Because see, when Pb in general reacts with water, no, it is going to create a oxide layer. Okay, a film of oxide layer will be created on its top, hence it is unaffected by water. Yeah, and the thing which I am saying is basically the element tin, basically it reacts with water and it is going to create the hydrogen. So students, as I have told you that when Sn is going to react with water, what it is going to form? Here let me tell you, the water that I am talking about, here tin will only and only react with steam. I just spoke, I guess hydroxide will be formed. No students, hydroxide will be formed. If we are reacting it with steam students, oxide will be formed. Here SNO2 will be formed. What will be formed ma'am? SNO2 will be formed. So this is basically a reaction that only and only tin can react with water and it can form its oxide basically. Rest everybody cannot do that. If I'll talk about carbon, silicon and germanium, they are not affected by water. But if I'll talk about lead, it is unaffected because it is going to form a protective oxide film layer over there. Yeah, and rest tin reaction is only and only possible, but that also with steam. Ma'am. Clear everyone? Okay, now let's move on to the next one, that is reactivity towards halogen. When I'm talking about reactivity towards halogen, see students, except carbon, all other members react directly with halogen under suitable conditions to make the halides. Yes, okay. Now let me tell you, over here you should know that when it is when our elements basically are present in +4 oxidation state, what are they going to form? They will form CX4, right? Then it is SiX4. Then it is next is going to be what? Now see, it is GeX4, then it is SNX4, then it is PbX4. So basically these are the compounds that are being formed. Now what is the question asked over here? Thermal stability question can be asked. Which question ma'am? Thermal stability question can be asked over here. Okay, now they can ask you which has the higher thermal stability. What is thermal stability? That means you are providing heat in order to break a bond. Let me tell you students, the one which has a lower atomic radii, you have to give a lot of energy to break that bond. Why? Because their force of attraction is very, very large. They have a lot of strong force of attraction, that's why. So we'll talk about the thermal stability, which has the higher thermal stability. This is going to be my order for thermal stability, because as soon as you are increasing the atomic radii, the distance will increase, force of attraction will decrease, and you can give a less amount of heat to break the bond. But in the case where there is an atom small, you have to provide it a very large amount of energy in order to break that bond. That means in the case of CX4, thermal stability is going to be very, very high. Okay, now let me talk about the next part. Most of the MX4 are covalent in nature, they are saying, except SNF4 and PbF4, which are ionic in nature. They create an ionic bond. Okay, here we have cation and an ion over here. Electrostatic force of attraction is observed. But students, it is a very, very important part. PbI4 does not exist. Because I over here, I negative over here is acting as a strong reducing agent, so it does not exist, students. PbI4 does not exist. This is an important key point that you should very well know. Now comes the next point. Stability of dihalide increases down the group. So if you are creating a dihalide, its stability will increase. Why its stability will increase, ma'am? Because lower oxidation state value is going to increase, higher oxidation state value is going to decrease. It's a very simple part. So we can clearly say over here that stability of dihalides is going to increase down the group. Clear with this part? Everyone just take a note, write each and everything over here so that I can move on to the next part of mine. Yes, everyone, just take a minute, write each and everything which I have clearly mentioned over here. Done. Now I am going to do the hydrolysis of halides. First of all, take a moment, do this down so that I can start with that part. See students, now comes hydrolysis of halide. See, in hydrolysis of halide, what happens if I have SiCl4 and I am going to do its hydrolysis. Now you can create a hydroxide over here. Now in hydroxide, students, SiOH4 is created out. Okay, so this is basically a reaction, that is hydrolysis of the halides, and HCl will be liberated out. Such questions can be asked. If I'll ask you about CCl4 reacting with water, so there is no reaction, students, taking place. Here it is no reaction taking place, just keep a note. Here it is no reaction, ma'am, taking place. But with SiCl4, if you're reacting it with water, hydroxide is created out. Clear, everyone? Clear with this part? Okay, ma'am. Now students, we are going to start with the allotropes of carbon. So let me tell you, basically we are going to cover the three allotropes over here, the diamond form, the graphite form and the fullerenes form. So starting with the first form, that is the diamond form. Now see students, in diamond form, it's very simple. Carbon has a hybridization of sp3, which is a tetrahedral shape, and each carbon atom is linked with 4 other carbon atoms. Each carbon atom is linked with 4 other carbon atoms. It creates a tetrahedral shape. It has an sp3 hybridization. Also students, it is a 3D network. It is a 3D structure that you are going to observe in the case of diamond. In the case of diamond, you can clearly observe it is a 3D network. For example, this is a carbon. It is connected in such a way with other carbon atoms. Clear, everyone? So it creates a tetrahedral shape, and that it is further connected out. And students, you very well know about, such questions are generally asked. What is the hybridization? What is the shape over here? Such questions can be asked. If I'll talk about the second form of carbon, the second allotrope over here, that is going to be what, ma'am? It is going to be graphite over here, students. But in graphite, let me tell you, carbon is present in which oxidation state? It is present in sp2 hybridized oxidation state. So this is a very different thing that I am explaining you over here. In the previous case, when I was explaining you about diamond form, students, what was happening in the diamond form? Here it was a tetrahedral shape. It was connected with the 4 other carbon atoms. But in the case of graphite, it's not true, students. In the case of graphite, the hybridization is changed out. Yes, everyone. First of all, everyone write down this part. Then I'm going to tell you about thermodynamically which is more stable, and kinetically which is more stable. See, such question can also be asked, which is stable thermodynamically and which is stable kinetically. So you should know about this as well, everyone. Just take a minute, write this important key highlights. I am just mentioning the important key highlights over here, but if you want to read from NCERT, you can go with that part as well, okay, and you can learn the important key points. Now students, I always say that whensoever you are studying for inorganic chemistry, you should have NCERT book with yourself, because you have to underline over there the important key highlights, the important major points. Yes, everyone. Okay. Now, I hope so you all have written for the diamond form. Yes. I hope so students, the diamond form, the graphite form, the fullerenes form, about all of these structures you have already covered in the class 10th standard, if you have learnt over there. Do you remember the fullerene structure? Whensoever we think about it, it is basically a soccer ball like structure, yeah, which contains 60 okay carbon atoms that we talk about, and in that particular part also we have different structures over there, yeah. We have an hexagonal ring over there, we have a pentagonal ring over there, and they are so connected with each other. Don't worry, we'll be coming to that part, but yes, you need to write down these important key highlights over here so that I can move on to the next part. Okay. So now I'm going to write with the graphite. As I've already told you, it is sp2 hybridized, students. If you want to mention over here that what exactly is happening, why it is sp2, because it creates, weak pi bonds. It basically, creates weak pi bonds due to which its hybridization is sp2 hybridized. Now the question they generally ask you over here only, diamond can exist in carbon can exist in diamond form, graphite form, fullerenes form. In diamond form, if you will talk about, it is going to have sp3, in graphite it is sp2, and in the Buckminster fullerenes they are going to ask that which kinds of bonds are there, okay. So everyone, just take a minute, write this down as well. Now let me tell you the types over here, types of graphite. See, in graphite, students, it is now of two types, alpha type and a beta type. Alpha graphite, the second one is beta graphite. If I talk about alpha graphite, it shows an AB type of structure. AB type of structure. If I talk about a beta graphite, it shows an ABC type of structure. Now students, I don't know whether you know about solid state chapter or not. In class 12 standard, you're going to have a solid state chapter in which they will be telling you about the structures, how the atoms basically arrange themselves. So we basically have an hexagonal close packing and we have, a cubic close packing. So AB type basically is your hexagonal close packing that you will be observing over there. And there is also a, cubical close packing. So that is basically the ABC kind of pattern. Okay. Okay. This is about the two forms, the two types of graphite, that is alpha graphite and the beta graphite form. Moving further, students, as I've already told you that we are going to do the third part, that is fullerenes. That is fullerenes. And if I'll talk about fullerenes, here we have carbon 60 over here. Okay. And it is a soccer ball like structure. We have in hexagonal rings, we have hexagonal rings, we have pentagonal rings, and both are connected with each other. Both are connected with each other. Okay, hexagonal rings will be attached to the pentagonal one, pentagonal will be attached to the hexagonal one. Right, everyone? Just take a minute, students, write down about the fullerenes part. Write down about the fullerenes part, everyone. Done with this part, shall I move on to the next one? Okay, now one more thing, students, as I was asking you a question that thermodynamically diamond is more stable or graphite. So basically graphite is thermodynamically more stable structure then diamond. Clear? Okay, now if I'll ask kinetically which is more stable, diamond is kinetically more stable than the graphite form. Clear everyone? They are going to ask a question with regard to thermodynamical stability, with regard to the kinetic stability, so you can answer them accordingly. Yeah. If I'll talk about graphite, so graphite is thermodynamically more stable. If I'll talk about diamond, it is kinetically more stable. And they're going to ask you questions with the comparison of graphite and the diamond form of carbon only. Clear everyone? Just take a minute, write them down. Now students, we are going to start with the compounds related to the carbon, that is carbon monoxide and carbon dioxide. Then we'll be moving on to the silicon parts. Okay, what is silicon, what is silicates, what is silicon dioxide, we'll be understanding about them. Okay, so starting with the very first is carbon monoxide. You very well know carbon monoxide is CO, which is neutral, which we have already studied about, that it is neutral. Yeah, now moving further about the properties of carbon monoxide, students, let me tell you, it is a colorless, it does not have any color, it is odorless, it does not have any smell, odor means smell, okay, and almost water insoluble gas. What they said, they are almost water insoluble gas. It is a powerful reducing agent. Now let me tell you students, this is a very important key highlight, that it is a powerful reducing agent and reduces almost all the metal oxides other than those of alkali and alkaline earth metal, aluminium and a few transition metals. Okay, next part. In CO molecule, now this is important about the structure, there are one sigma bond and two pi bonds, okay, between the carbon and the oxygen. Remember students, the very first bond that is created is a sigma bond and the other bonds that are created are the pi bonds. Okay, so you can clearly see this is a structure of a carbon monoxide, that is CO. Coming to the next part, because of the presence of a lone pair on the carbon atom, carbon monoxide molecule act as a donor because it can donate, and if it can donate, it can react with certain metals when heated to form metal carbonyl. So this is a very important speciality, I would say, a good speciality, I would say, that it can react with metals to form metal carbonyl like structure. Why? Because it contains a lone pair of electron in itself. Coming to the next part, students, here we have the highly poisonous nature of carbon monoxide arises of its ability to form a complex with hemoglobin, which is about 300 times more stable than the oxygen hemoglobin complex. This prevents hemoglobin in the red blood corpuscles from carrying oxygen around the body and ultimately resulting in death. Yeah, so you can see it's the biological importance that we are studying with regard to the human body. Okay, now students, moving on to about how is carbon monoxide prepared. So we are now going to start with the preparation of carbon monoxide. So when I'm talking about carbon monoxide, the very simple basic reaction is when carbon reacts with oxygen, when carbon reacts with CO2, it forms carbon monoxide. When carbon will react with oxygen, it will form carbon dioxide. But when it reacts with CO2, carbon reacts with CO2, it will form carbon monoxide. There are certain reactions, students, such as now I am going to tell you about the laboratory method. This is the lab method. In lab, how you are going to prepare carbon monoxide? So it's very simple. You are going to take, HCOH. Okay, COH basically is the carboxylic acid, basically the carboxylic group that is attached over here. Yeah, so this is the simplest carboxylic acid we are taking over here. At 373, when we are going to react it with concentrated H2SO4, it is going to liberate carbon monoxide and water. So this is a lab method, students, in order to prepare carbon monoxide. Coming to the next part, let me tell you, students, carbon when reacts with water, with at a temperature of 473 to 1273 Kelvin, it is going to give us what? Carbon monoxide and H2, and this is water gas. This is water gas or syngas that is being produced. You should know about this, okay? Syngas, water gas that is produced. It is a very, very important reaction, everyone. Very, very important reaction for the method of preparation of carbon monoxide over here. Coming to the next part, students, there is also one more reaction. They can generally ask you what is the producer gas. So when carbon monoxide and N2 is liberated, that is a producer gas. Now how ma'am it is liberated out? Let's see. See, when you are going to react carbon with oxygen, okay, also with N2 at 1273 Kelvin. Okay, so you are going to obtain a mixture of carbon monoxide and N2. This is referred to as a producer gas. So see, water gas question is generally asked, what is a syngas, what is a water gas? That is the sum of carbon monoxide and H2. But yes, when you are obtaining, carbon monoxide and N2, that mixture is a producer gas. Remember this part because it is very, very important, okay, part over here. Coming to the next part over here, students, let's talk about carbon dioxide. Carbon dioxide is CO2 and I have told you already it is acidic. It is acidic, yes. So starting with carbon dioxide, it can be obtained as a solid in the form of dry ice, okay, by allowing the liquefied CO2 to expand rapidly. Moving further, students, about dry ice, let me tell you, dry ice is used as a refrigerant for the ice cream and frozen food. Gaseous CO2 is extensively used to carbonate soft drinks, right? So basically in the chapter solution also we have read about this in the Henry's law topic, yeah. Moreover, we have done a lot of, we have understood about that, what is the role of gaseous CO2 in that part, yeah. How pressure is applied and what is the role in soft drinks. So we have done that already, yeah. Now, being heavy and non-supporter of combustion, it is used as a fire extinguisher, which is a very, very important use of that. Moreover, a substantial amount of CO2 is used to manufacture urea. Coming to the next part, students, here comes the preparation of carbon dioxide. So when I am saying carbon dioxide, that is basically CO2. How is CO2 obtained? Now only when I was telling you about carbon monoxide, I told you carbon plus CO2 gives CO2, carbon plus CO2 will give you carbon monoxide. But if you want to obtain dioxide, you have to react carbon with oxygen. It's a very, very basic, simple reaction. One more reaction, students, that this is a when, you take in any hydrocarbon. Here I am saying any hydrocarbon you take. And when you are reacting that hydrocarbon, generally the alkanes one, with oxygen, you are going to get CO2 and water. What are you going to obtain, ma'am? We are going to obtain CO2 and water. Carbon dioxide is produced. There is one more reaction, students, that is, the industrial way to prepare that. That is, when you heat CaCO3, you are going to obtain, the calcium oxide as well as liberating CO2. Yes, everyone. I hope so. This is also so clear to each and every one of you. This is basically the methods of preparation of carbon dioxide. Clear with this part? Okay, ma'am. Coming to the next one, we are going to start with silicon dioxide. What it is, ma'am? Silicon dioxide. Now, silica in its normal form is almost non-reactive because of very high silicon and oxygen bond enthalpy. Okay. Now, it resists the attack by halogens, dihydrogen and most of the acids and metals even at elevated temperature. However, it is attacked by HF and NaOH. Let me tell you about silicon dioxide in general, how it is going to look alike. So basically, this is a kind of a sort of structure that you observe for, So students, such kind of structure you can observe for silicon dioxide. Everyone just draw the structure over here so that I can move on to the next part. Yes. Just draw the structure of silicon dioxide. Let me tell you, here the linkage is quite, it's like this. It is a 3D structure. It is SiO2. Here is Si, then it is linked. SiO2. Then also it is like this. Here is also one oxygen and then is silica. Here is one oxygen, then is silica. Yeah. So basically it is somewhat like this structure. Clear, everyone? Just take a minute, draw the structure out. This is a structure of SiO2. From here you can draw this. No need to create a 3D structure, just to make 2 layers, that is sufficient. This is a structure of SiO2, students, that is silicon dioxide. There is a linkage of silica, oxygen and then silica. Silica, oxygen and then silica. Clear, everyone? Clear with this part? Okay, ma'am. Let's start with the next part now, students. The thing over here that we are discussing about silicon dioxide is, there are such more informations provided to you for the usage, where it is used basically. See, quartz is extensively used as a piezoelectric material. Now, question is asked from this in the competitive exam, if you'll observe, okay. It has made possible to develop extremely accurate clocks, modern radio and television, broadcasting and mobile radio communications. Silica gel is used as a drying agent and as a supporter for the chromatographic material as well as the catalyst. Okay. And then they have given you certain example. The amorphous form of silica is used in the filtration of plants. So this is basically where silica is generally used. Everyone just take a minute, write down. Now I'm going to tell you about, what are silicones, what are silicates. We should know about that as well. Yes, about silicones, about silicates. Take a minute everyone, then we'll be moving further with the next part of ours. Okay, now students, I'm going to start with the silicones topic. If I'll talk about the silicones topic, first of all, how are you going to prepare silicones? What is the structure? Let's talk about it. So silicon basically is when you are reacting it with RCl. Now this is basically alkyl halide. You are taking an alkyl halide. You are reacting it with silica. In the presence of Cu, you are going to get R2SiCl2. What are you obtaining? R2SiCl2. Now this R2SiCl2 on further reaction with water is going to obtain you what? R2SiOH twice plus HCl. Now let me tell you what is the structure. How is the structure? Let's draw this. We are going to draw first of all this part. See, now we have one silicon. It is attached with R group over here, with R group over here. And then is oxygen hydrogen, then is oxygen hydrogen. Let's draw one more structure over here. So this is basically I have drawn this structure. Now on the next page I am going to show you how silicones are obtained. Let me show you. See, basically this is silicon, here is oxygen, hydrogen, here is an R group, here is oxygen, here is hydrogen, here is oxygen, here is hydrogen. Let's draw one more structure. Silicon, oxygen, hydrogen, oxygen, hydrogen, R group, R group. Now let's take one more. Basically it is hydrogen, oxygen, silicon, oxygen, hydrogen. Here is another R group, here is another R group. Now let me tell you students, you have to remove water molecule over here. See, if you are removing OH from here, you have to remove H from here. If your H is removed, here again OH will be removed, H will be removed. So you have to remove water molecules. What is the structure you are going to obtain? See, from here if OH is being removed, here H will be removed out. So you are going to obtain what? See, here OH is, see, from a structure, one OH and H will be taken out. If from here OH goes, here H will go. So you are going to obtain O, then silicon, then here is O, sorry, here is R. Here is an R group attached, no? Here is R. Yeah, and here then it is, see, this is removed, so we have one oxygen at the center, then is silicon, then is R again over here, then see, this is removed, we again have one oxygen at the center, then we have silicon, then we have this. Okay, now from this hydrogen is removed, from this OH will remove, so it is like this. Now coming to the lower part, we have an R group over here, we have an R group over here, we have an R group over here. Yes. Now see students, this is what is the polymer created over here. So can I put N over here, because this is so repeated after this. Over here students, it will be connected to the next silicon structure. Over here this will be connected to the oxygen and the next silicon structure, to the oxygen atom and then to the next silicon structure. Just draw, this is basically the silicon obtained. Clear everyone? This is basically how the silicon is being obtained. It is basically used as the waterproof clothes, for waterproof clothes. That means it is used in preparation of raincoats. Okay. This is what is silicon. Clear everyone? This is what is silicon obtained. Everyone just take a minute, write it down, then I can start with the silicates part now. Let's start with the silicates part now. So now students, we are going to start with the silicates. See students, in silicates the general formula is SiO4 minus 4. This is the general formula for silicates. Silicates are further categorized into many types. Okay, the first one that you're going to study is going to be orthosilicates, pyrosilicates, and then the cyclic one, and then your chain silicates. Okay, these are basically the silicates that I'm talking about. Now when I'm saying SiO4 minus 4, how it generally looks like, this is Si, one oxygen over here, another oxygen over here, another oxygen over here, another oxygen over here. Each oxygen carries a negative charge. It basically is a tetrahedral shape that is being obtained over here. It basically holds a tetrahedral shape. Whom I am talking about? Silicates, which has a general formula of SiO4 minus 4, everyone. Okay with this part? Clear with this part? Okay, ma'am. Shall I start with the next part now? The next part is, now I am going to tell you the types of silicates. Students, silicates are further classified as orthosilicates, pyrosilicates, cyclic silicates and chain silicates. Yes, everyone. So, starting with what is ortho, what is pyro, what is cyclic, what is chain like a structure. See, it's very simple. Here you have to see about the linkage of oxygen atom. That where one oxygen atom is linked, where two oxygen atom is linked, this is so important part. First of all, students, write down what is an orthosilicates. So, orthosilicates has an example of Mg2SiO4. It has an example of Mg2SiO4. Now, I am going to tell you their structures. First of all, write down the examples. In pyrosilicates, example is Si2O7 minus 6. Si2O7 minus 6. Let's talk about the cyclic structure. It is Ca3Si3O9 and it has a general formula of SiO3 minus 2N. Chain silicates also have this general formula SiO3 2 negative N. Chain silicates also have the same formula. Okay, but example in the chain silicates is lithium, aluminium and then Si3 twice. The same that I am using over here. Si3 twice over here. Yes, everyone. So, these are the examples of the types of silicates that they generally ask you directly in the questions. I will be writing some of the homework questions over here so that you can get an idea how ma'am questions are generally asked in the exams. Yes, everyone. Just take a minute, write down so that I can tell you now the types of silicates. Now, let me tell you, as you have seen the previous structure of silicones, what was happening? We were just removing water molecule. Over here, what is happening? In the previous case, if you can clearly observe, here this oxygen is linked with some another silicon. Here will be one oxygen linked with another silicon. So, here in this silicon structure, silicate structure also, you have been seeing the oxygen atom. This is linked with further, right? But in orthosilicates, there is no linkage of oxygen atom between them, between two silicates. Between two silicates, no oxygen atom linkage is being observed. Okay. Now, before telling the next type also, students, let me tell you one more structure of silicates that is generally seen. See, I am representing, silicon as like this, okay. If I am representing it, it is like this. It is attached with, let's say the 3 silicates. 3 oxygen atom. It is like this, O negative, O negative, O negative. Now, see, in general, if you have to see the 3D structure, you see that silicon is present at the center metal atom represented as a circle, connected with 3 oxygen, one, which is in front of me, one at the top and one is basically at the, right hand side in the plane position. But one is present at the back. The back one oxygen atom is represented as a circle over here. So, this is also an oxygen, which is O negative again. All of these oxygen carry negative, negative, negative charge. So, this is one more representation that you can obtain for whom? For ma'am silicates. Yes, everyone, take a minute, draw this structure over here as well. Now, we are going to talk about, the next part. The next part, that is pyrosilicates. See, in this, no linkage of oxygen atom is obtained. Here, one oxygen atom is linked. Oxygen atom is linked. Clear? And if I talk about cyclic silicate, students, in the case of cyclic silicates, what is going to happen over here? Ma'am, in the case of cyclic silicates, 2 oxygen atoms are linked. Okay, it creates a cyclic like structure. Here 2 oxygen atoms are so linked with each other. And chain silicates, it's very simple, a chain is created. Yeah. Clear, everyone? So, these are the types of silicate, students. Now, students, I am going to proceed further. I am going to tell you, that some questions based upon this topic that we have done so far. Yes, everyone? Just take a minute, write this down. Then I am going to tell you some of the questions. So, students, now I am going to write some of the questions over here, okay, as your homework. and you have to solve them questions. Now see students, what is going to happen, see, I am going to answer them in the comment section. I am going to pin on the answers over there. You can cross check your answers over there with me, okay? And on the previous classes also, the questions that I have given as a homework, I will be writing their answers in the comment section. You can go and cross check over there. So I am mentioning some of the questions over here. Let's see whether you know this or not. Now we have done each and every part. If I am going to write a question over here, you will be answering at that spot only. See the first question. They are asking PbO2 is. What is PbO2? A option basically is, it is basic. B option, it is basically acidic. C option is, it is neutral. And D option is, it is amphoteric. Now see students, it's very, very easy. It's very, very easy. If you remember, if I was talking about dioxides, I already told you what, ma'am, that initial were acidic and the last one were amphoteric. Simple, so now you know the answer. But yes, I want you people to think about it also, yeah. Moving on to the next question. This is first homework question. The second question, though I have told you the answer, but I guess still many people will be there who are not getting what I am saying. If you have heard the topic, it's very easy. See, such easy question. Now let me tell you, this was asked in JEE 2000 question paper, okay. Now I have brought, the questions that I am having over here, I am going to write over here are either from the previous year question papers, okay, or from the good books. So please try to solve them out. The next one is, okay. Which anion is present in chain structure of silicates? Yes everyone, in chain structure. So A is basically Si2O7 minus 6, B is Si2O5 minus 2 and then is N. C basically is SiO3 minus 2 and here is N, while D is SiO4 minus 4. Yes everyone. So this also we have done in the previous slide itself, the chain structure of silicates. We have seen the 4 structures which I have already told you, ortho, pyro, chain and the cyclic one. So I guess you know the example of this as well. Yeah. Okay, let me give you some more questions. I guess 2 questions you have written. Yeah. So the next question basically is, which element is a non-metal? Yes everyone. So over here the first is gallium, B is indium, C is thallium, while D is boron. Clear? Now the next question is, I am giving over here, which of the following is electrodeficient species? Electron deficient species, okay. A is B2H6, B is C2H6, C is PH3, while D is SiH3. Now this also students, I have told you the complete structure in the previous class. So I hope so you can clearly tell me the answer for this particular question also. Okay. Now the last question is, which metal has a greater tendency to form metal oxides? Okay. A is aluminium, B is calcium, C is chromium, while D is iron. Okay. Students, try to solve this question out. Okay. Though we'll be meeting again and again on the PW English channel. We'll be discussing the questions as well. Right everyone? I hope so students, now this journey was as wonderful as it was for me, and I feel that we have completed the inorganic chemistry part. Now it's your turn to read the NCERT, read the important key highlights, and yes, whatsoever comments you have written so far for inorganic chemistry topics, I will be now taking, in a day I will be answering to each and every comment over there. You will be observing me giving you answers for the questions that you have asked. Clear everyone? Now thank you so much. Have a good day. All the very best for your upcoming journey students. Take care of yourself. Thank you so much. Have a good day.